Good day everyone, especially to our dear panelists. My name is Dara Vivien V. Briñosa,
And I'm Earl Joseph Ferran,
and we are here to present our project entitled Solar Powered H2O Generator. Let me first explain the title of our project, Solar Powered H2O Generator. H2O means hydro-oxygen. It is hydro-oxygen because our device is for water and it generates oxygen.
We came up in this study because of the problem observed.
The first problem is the stagnation of water in the fish pond. Everyone knows that ponds needs oxygen in the water for the fish to survive. Water of fish ponds that is left undisturbed can quickly be contaminated with pests and affects livestock greatly.
Another problem is growing demand and scarcity of energy. Today we are facing the lack of electrical energy, and it's important for the people to move towards to the renewable resources. As a solution of the problem, we developed a solar-powered H2O generator.
The solar-powered H2O generator is a device that aerates water from the fish pond by breaking water into fine drops or bubbles using paddle wheel. It is an automated device that is powered by the solar energy and has the ability to detect the water temperature to perform its assigned function to a specific situation. In developing the solar-powered H2O generator, we aim the following objectives.
Design the solar-powered H2O generator, its circuitry, and prototype.
Develop the solar-powered H2O generator using Arduino microcontroller board.
Evaluate the product in terms of reliability, functionality, ease of use, and safety. For the beneficiaries of the project, we have fish, Minskat Bungabong Campus, vendors, citizens near the fish pond.
For the fish, the oxygen that they may get in the solar-powered H2O generator help the fish to grow healthier and it will give them better habitat. For the next beneficiary, the Minskat Bungabong Campus. This project is useful for Minskat Bungabong Campus. It will help them to harvest good fish that is used for research and marketing purposes. Next is the vendors. Having good environment for the fish help them to grow healthier and also increase the population of fish. Since there is a good and more harvest of fish, they might increase their sales. And lastly, the citizens near fish ponds. Living near the ponds sometimes bring danger. Stagnant water in the pond, especially in brackish water ponds, may become the breeding ground of mosquitoes. The solar-powered H2O generator will naturally disrupt the breeding habitat necessary for mosquitoes. The following are the related literature and studies of solar-powered H2O generator. First, for the foreign literature from Aquascape, it stated that every biological process that occurs in ponds was dependent on oxygen and pond aerators supply. Pond aerators supply dissolved oxygen directly to ponds and other water features, helping all biological processes and resulting in healthier fish and plants. For local literature, from Joven C. Kalasagsag, 2014, he cited that bangus production in Suwal town goes high-tech with the pilot experimentation of a solar-powered aerator system as a defense against fish kill and to improve the cultivation in the article Solar Aerator for Bangus Production Launch. For foreign study, from I. Prasetchaninsari and A. Setchawan 2013, according to their study, based on geographical region, most of fish pond was located away from power lines. So, it was necessary to use local potentials of renewable energy such as solar energy in the aerators. And lastly, for local study, from T. Bagarino and I. Lantin Olaguer, 2006, according to them, aqua farms with high organic load limited water exchange and circulation, no aeration, and high stacking and feeding rates can become oxygen depleted and allow sulfide from the sediments to appear in the water column and poison free swimming fish. Aquafarms must be well oxygenated to prevent sulfide toxicity and fish kills.
For the conceptual framework, first, a solar panel that absorbs the sunlight, then goes to the solar charger controller that converts the light energy to electrical energy that will store to the rechargeable battery, then go into the voltage divider to power the Arduino. Then the sensor gives the data to the Arduino, then the Arduino will control the motor driver, and the motor driver will control the motor with to rate or to the motor rotate. Then for the power backup, we put a voltage detection sensor to the rechargeable battery to detect its voltage, then give the data to the Arduino to switch AC-DC converter in case of low voltage to continue the aeration. Then it controls the motor driver, then control the motor, then continue paddling with the AC-DC converter.
For the conceptual paradigm, input consists of the requirements needed in developing the solar-powered H2O generator. First is the knowledge requirements, software requirements, and the hardware requirements. Under the knowledge requirements, there is planning and data gathering, and concepts, ideas, and related literature and studies. Under the software requirements, there are Arduino software and the language, which is the Arduino programming language. And for the hardware requirements, there is tools and equipments for prototyping, Arduino board, solar panel, solar charge controller, DC motors, battery, relays, temperature sensor, and the real-time clock module.
To develop the project, we follow the step of engineering design process, which are problem identification, research, requirement specification, concept generation, design, prototype and construct, system integration, system test, and evaluation.
After the input and process, we have the output, which is the solar-powered H2O generator. For the methods and procedure, the solar-powered H2O generator was developed by following the steps of the engineering design process by Ralph M. Ford and Chris S. Colston. The first step is the problem identification. Problem identification is the process for which the researchers state their problem and determine the needs of their desired consumer.
Problem: stagnant and contamination of water leads to decrease of dissolved oxygen or DO and sometimes fish kills.
And another problem is unstable power source and power interruptions that may affect performance of the project.
For the solution, solar-powered H2O generator is an automated aerator that operates through the use of solar energy with a backup AC supply for emergency purposes.
In research phase, in this process, the researchers conducted researches on basic engineering and scientific principles, related technologies, and existing solutions.
The researcher found the foreign and local related literature and study about the solar-powered H2O generator. Those literature and study helped the researcher know the principle about their subject and determine the right information applicable for the project, and also gave them the needed information to be able to design and create the project. For the system specification, this process articulates what the system must do for it to be successful and to be accepted by the customer.
The solar-powered H2O generator is powered by the solar energy. Through the use of solar panel, the sun's rays are absorbed and it was converted into DC power through the use of solar charge controller, which was stored in the DC battery. It detects the water temperature through the use of waterproof temperature sensor and determines the time through the use of real-time clock module. The device operates when it detects that the water temperature is 20 degrees Celsius and below, and stops if the temperature rises above 20 degrees Celsius. The device changes its supply to AC supply when the battery was low.
For the concept generation, the researcher got the ideas from the related literature and study. Those related topics help the researcher to gather information needed for their project.
In design phase, the researchers used freezing software for designing the circuitry of the solar-powered H2O generator. They also created a flowchart which shows the flow or the sequence of process that was happening on the project. They created a layout for the actual picture of the project through the use of the Google SketchUp.
Flowchart. These show the flow and the sequence of the process. First, start, then going to the solar panel that absorb the sunlight, then convert it to the electrical energy to store to the rechargeable battery. Then, going to the voltage detection sensor. If the battery is below 30%, it will switch to the AC-DC converter that's going to run the system. Then, if it is not below 30%, will go again to the rechargeable battery and the system will run. If the temperature is below 20 degrees Celsius, the motor rotates, and if it's not, the motor will stop rotating. Then the process will repeat again and again until it executes the process. In the next page, if the time is 8 p.m. to 6 a.m., the motor will rotate. If it is not, the motor will stop and it will repeat again and again until it executes the process. For manual method, in turning on, if it is turned on, the motor will rotate. If it is turned off, the motor will stop rotating. Then, in the process, turn off and it will end the process.
This is the design of the paddle wheel.
First, we have a paddle wheel, sprocket, DC motor, and bicycle chain, floating device or water drum.
And this is the design of the circuitry box.
We have here the switch, motor driver, servos. Between the servos, we have potentiometer and liquid crystal or LCD, and voltage detection sensor that detects the voltage, then Arduino Uno and shield, temperature sensor and RTC module, the DC buck converter, and the relay. For the outside, we have the panel, solar charger controller, LCD, potentiometer, and temperature sensor. Inside the box is the 24 volts battery. The next one is the schematic diagram. It shows the connection of the component to our microcontroller Arduino Uno.
And we have here the legend. The red lines represents VCC and the black lines represent ground.
We have here the solar panel that absorbs the sunlight, goes to the solar charger controller to be stored in the rechargeable battery. Then the potentiometer that connected to the analog pin of the Arduino, then a voltage sensor that connected to the 24 volts battery and connected to the analog pin of the Arduino Uno. Then a temperature sensor that connected to the analog pin. Then motor driver that connected to the power supply to rotate the motor. Then it connected the one potentiometer to control the speed of the motor. Then two servos that connected to the digital pin of the Arduino to that attached to the potentiometer to rotate it automatically. Then a relay that connected to the digital pin for automatically switching for AC-DC converter or rechargeable battery. Then LCD is connected to the RTC and that connected to the I2C pin of the Arduino Uno.
For the prototype and construct. During prototyping and construction process, the researchers gathered the hardware, software, and knowledge required. All the electrical components were tested, plastic containers and acrylic glass were cut, and irons are welded.
For the program code of the project, the researcher created a programming code which was uploaded to the Arduino microcontroller board and debugging errors were also conducted.
In system integration phase, in this process, all the subsystems were brought together to produce complete working system. This phase involves soldering of components and putting all the components in the prototype of the project.
In this process, all the materials that have been gathered, cut and welded, and the components that were tested were put all together. Testing and troubleshooting were involved in this process.
In system test, in this phase, functionality of the project was tested.
The solar panel works and the battery recharge. The paddle wheel activates if the temperature sensor detected the temperature is 20 degrees Celsius and below, and deactivate if the temperature rises. When the battery is low, the power source will switch into AC supply.
System was easy to use and did not cause any harm to the user.
For evaluation, the researcher aims to meet the following criteria: reliability, functionality, ease of use, and safety.
We conducted an evaluation to 30 respondents, 10 from students of Misgat Bungabong campus and 20 from the community. To measure the quality of the project, we used Likert scale.
For design consideration, a good design and safety for consumer was the main concern of the researchers in developing the design of the project.
The researchers made sure that all electrical components were safe from water splashes, so the circuitry box and the motor was sealed with an insulator material.
To avoid the rustiness, all iron-type materials were painted.
So let's proceed to the electrical assembly.
And we have here the switch, motor controller, servos. Between the servos, we have a potentiometer that rotates automatically, and liquid crystal display or LCD that display the information or the data that gathered by the sensor. Then a voltage detection sensor that connected to the rechargeable battery. Then Arduino Uno and Arduino shields. Then the temperature sensor and RTC module is attached to the shield. Then a DC buck converter and a relay for switching to the AC-DC converter. Then in the outside part, we have here the solar panel, solar charger controller, LCD, potentiometer for the manual switching, then a temperature sensor, then inside we have a 24 volts battery. This is the AC-DC converter. This portion is connected to the AC supply, then its output is connected to the relay.
Let's proceed to the mechanical assembly.
In mechanical assembly, we have a motorcycle bicycle chain that connect the paddle wheel and the motor, then a paddle wheel, then a water drums to float the device, then a square bar to support the prototype.
And we also have pillow blocks We have the pillow block to allow the rotation of the paddle wheel.
Then the circuitry box that made of acrylic glass and its housing was made of liso.
So let's proceed to the hardware process. The solar panel will absorb the sunlight and send it to the solar charge controller. This energy will be converted into electrical energy and is stored into 24 volts battery. We have the voltage detection sensor that detects the value of 24 volts battery. If the value is low, the device will be switched its power source into AC. And when the battery is fully charged, the power source will be switched again into DC.
And this portion is for controlling the motor. We have here the RTC module that determines the time. If the time is 8 p.m. to 6 a.m., the servo that was attached to the potentiometer is attached to the motor driver controller that control the speed of the motor. Then in the daytime, we have here the temperature sensor. If the temperature of the water is below 20 degrees Celsius, the servo will rotate that connected to the potentiometer of the motor driver controller that controls the motor. That all data is displayed to the LCD.
Fabrication of the mechanical parts and interfacing of electronic control. In the fabrication of mechanical parts, the minimization of space was taken into consideration to avoid grounds that may happen in the circuitry. The circuitry box of the project was made of acrylic glass. The solar panel, 12 volts battery, and the circuitry box were put together in one housing. The DC motor was put in an insulator case so that it will be protected from being soaked in the water.
Simulation, testing, and troubleshooting. Trial and error were done during the programming of the code for solar-powered H2O generator. To solve the problem during the simulation and testing, the related study, literature, and tutorials from internet help the developer in troubleshooting the syntax and logical errors.
For project testing, solar-powered H2O generator was tested to ensure that system met the requirements. Before the system's implementation, the researchers made sure that the system was reliable, easy to use, and won't cause any harm to the desired consumers. Final troubleshooting was done when the errors and conflicts were encountered. So this is the computed mean of the project. The criteria of the evaluation are reliability, functionality, ease of use, and safety. For reliability, from 30 respondents, 23 rated the project as 5, 7 rated the project as 4, and the average is 4.77, which means excellent. For functionality, 26 rated the project as 5, 4 rated the project as 4, and the average is 4.86, which means excellent. For ease of use, 22 rated the project as 5, 7 rated as 4, and 1 rated as 3. And the average is 4.7, which means excellent. And for the safety of the project, 23 rated the project as 5, 7 as 4, and the average is 4.77, which means excellent. And the total computed mean of the project is 4.78, which is equivalent to excellent.
Findings. Solar-powered H2O generator was developed to provide the need for oxygenation of the fish pond in the automated way. The abundance of Earth in renewable resources such as solar energy was considered and was used.
Due to the very fast speed of the paddle wheel, water splashes to the motor and if not noticed, may infiltrate inside and destroy the motor. As a solution, the researchers put a plastic container to cover the motor from splashes of water. It has holes at the bottom so from the water was avoided.
Arduino microcontroller board, waterproof temperature sensor, real-time clock module, relay, voltage detection sensor, servo, potentiometer, DC-DC buck converter, motor controller, DC motor, 24 volts battery, and AC-DC power supply were used.
Following the steps of engineering design process by Ralph M. Ford and Chris S. Coulson helped the researchers in order to make the study effective and useful.
Based on the evaluation, it shows the project was reliable, functional, easy, and safe to use.
For the conclusion, based on the summary of findings and evaluation of the project, the following conclusions are drawn. The solar-powered H2O generator is designed as an automated paddle wheel that activates during nighttime and during daytime when temperature is low and can manually activated by the consumer.
Prototype and circuitry were designed and developed with the use of Arduino microcontroller, sensor, and was powered by solar-powered energy.
And the device was evaluated as reliable, functional, and easy and safe to use. Considering the result of the evaluation and conclusions, the following recommendations are derived.
It is better to use a bigger motor so that the paddle wheel will produce more bubbles or oxygen.
Use solar panel that is 100 watts so that the absorption of solar energy is better and storing of electrical energy is faster.
Keep the circuitry box far from the paddle wheel so that the splash of water will not reach it and short circuit will be avoided.
It is important to maintain the iron component of the project with grease so that rustiness will be avoided.
This is the part of our solar-powered H2O generator. First, we have motor, then paddle wheel, then a solar panel, controller, and the power supply.
So let's proceed to the function of the solar-powered H2O generator. Turning on the solar-powered H2O generator. For the manual method, to be able to turn on the paddle wheel, you have to rotate the potentiometer into clockwise. The speed of the paddle wheel is based on the rotation of the potentiometer. To turn off the paddle wheel, you will have to rotate the potentiometer into counterclockwise. For the automatic method, there is a water temperature sensor that detects the temperature of the water. If the water temperature is below 30 degrees Celsius, the paddle wheel will on. And when the temperature gets high, the paddle wheel will turn off. For storing of battery charge, there is a solar panel that absorbs the sunlight and converts it into electrical energy. This electrical energy was sent to the solar charge controller to the 24 volts battery. There is a voltage detection sensor that detects the value of remaining charge of the 24 volts battery. If this sensor detected that the battery is low, the device will switch its power source into AC supply. Turning off the solar-powered H2O generator. Again, I am Dara Vivien Briñosa.
And I'm Earl Joseph Alperan.
And that's all. Thank you.